we should have, and then we should have 1, 2, 3, 4, and 5. And then C, we decided was 1/8 by solving it.
Yeah.
Okay.
This one on it.
So it's 1/8, and then 2 eighths, and then 2 eighths, 2 eighths, 1/8. Okay? Now, things to know about these are called probability distribution tables. Okay? And all the totals of these should always add up to 1. So we can check our work. 1 plus 2 plus 2 plus 2 plus 1 should be 8/8. Okay? Now, the next question I have is, what is the probability that t is less than or equal to 3? In words, tell me, what does that mean, that t would be less than or equal to 3?
So it could be 1, 2, or 3.
It could be 1, 2, or 3, right?
1, 2, or
Correct, because it's or. So this, by definition, is the probability that t is 1, plus the probability that t is 2, plus the probability that t is 3. So it could be, yes?
But is it the little t or the big? Because isn't it like when you're saying 1, 2, 3, you mean
Well,
that 1, 2, 3?
So, remember, big T is this guy, and then that T is, the little t would have been 1,
Oh, okay.
right? And then the little t would have been 2, and the little t would have been 3. Does that make sense?
But it correlates to the numbers that we had up
So
there.
capital is just the thing.
Good story.
The thing, okay.
So, what is when t is 1,
1, 8,
right? What is when t was 2?
1, 4, 1, 2, 8.
Yeah, keep it as the same, I got all nervous. Keep it as the same denominator, easier to add, right? And then last but not least, t is 3. So this particular probability when t is less than or equal to 3 is going to be 5/8.
Yep.
Pretty good so far?
No.
Love you too, babe. Okay, what about the probability that t is bigger than 3?
Should be 4 and 5.
3.
4, 5.
So it'd be 4 or 5, right? So it's going to be the probability that t is 4 plus the probability that t is 5. Does everybody understand why you add? Because it's that or that,
Yeah.
right? And or means add.
Yeah.
So t is 4, 2 eighths. T is 5
1, 8.
for a total of 3 eighths. Are we good? Feeling good?
Why do you just do 4 and 5?
Because it's greater than, strictly greater than.
Yeah, so why don't you just why do you just use 4 and 5?
Because it can't be equal to 3, so it's got to be
No, I
4 or
know
5.
that, but,
Yeah.
you had 3 in the other problem, so why don't you do plus 6, plus?
Because 6 doesn't.
Oh, there's no 6 up here.
Oh, because.
Yeah, we only have 1, 2, 3, 4, 5.
Okay.
And yeah, okay. I wasn't sure of your question. Now I'm with you.
It's like going 5 cents a day. You can't get 6.
Can't, yeah.
It's the limit.
Right, there's that's the end of it. Okay, are we good there?
Mm-hmm.
Good, comfortable? Okay, now. Did I already do the spinner?
Yeah.
Did I do the, let's go to the, I don't think I did this one. I might have. Let's go to the fair and play the roll a die game? No?
We-
Okay.
Roll the die.
Yeah, you know.
Yeah.
Isn't the fair coming up, the St. Mary's Fair?
Yeah.
Yeah, so this would be, when you go up, now you'll be highly educated as to why you want to or why you don't want to play that particular game. You could use this to your advantage. Okay, so let's say we're going to play the roll the die game. Okay? Die being one dice. All right, it costs 50 cents. 50 cents for each try. Okay, so you walk up, you put your 50 cents down, right? Okay, if you roll a 6, you win $1.50. Everybody good? If you roll a 2 or a 4, you win 60 cents. Are we good so far? Okay. So I want you to construct a table. We're going to make the table, and we're going to let capital W, okay, be the random variable, winnings in cents. Okay? Remember, the capital is the story. So, we have to construct a table. Let's get the framework of the table set up. Okay. What's the letter that's going to be on the very tippy top? A what?
A baby W.
A baby W, yeah.
Oh,
A little guy. Good job. A baby W. And what's the guy that's going to be over here? Yeah, it's the probability pointy W, big W, is equal to a baby W, right? Are we good so far? Okay. So I walk up at St. Mary's Fair and I put my 2 quarters down and I roll a die, right? So let's talk a little bit about winnings, okay? So what do I mean by winnings? Well, basically, I'm thinking about every aspect of the game. What could potentially happen in the game? So let's talk about scenarios that could potentially happen in this game. So I put 50 cents down. What is this scenario? I roll a 6, okay. I what?
You have $1 net gain.
I get $1 net gain. That's important, okay? Okay, so I put the 50 cents down, I roll a 6, and they give me back $1, right? Does that make sense? Because it costs 50 cents to play. All right, so my winnings would be the $1. How about this scenario? I get the 10 cents. What's my last scenario?
Lose 50.
I lose, right? I lose 50 cents, right? Does that make sense? So how do we set that up as a thing? Remember, go least to greatest, like 1, 2, 3, 4, 5. You know how we always have least to greatest? So how would that be set up as far as my W's are concerned? You're not going to tell me, you're not going to show me the roll of the die, because we're actually doing it for the winnings.
So 0, 10, 100.
So it's not really 0.
It's negative 50.
It's negative 50, right? So it's negative 50 cents. Now, they argued with me earlier in the last time. They said, do we really put the 50 cents or do we just put negative 50? Because it says it in cents. You can argue that, you know, it's like, who crossed? I don't know. Chicken or the hen, you know, I mean the egg or the whatever. Both of them. They both had an egg. Which came first? Who knows? All right, so let's keep going. All right, what is the next scenario you guys told me? It was 10 cents, right? Because we would have had the 2 or the 4, right? And then last but not least,
100 cents.
right, or the dollar bill, however you want to write it. Again, it doesn't, if you put 100 cents, it's cool. If you put point, whatever. I mean, honestly, you could put in dollars. I don't know. It's up to you guys.
No,
But you get the,
it says in cents, should you put 100?
you should.
You're
That's
being consistent.
that's
with
the
it,
argument.
But like
Is it
often
problem-
should be 100. You're being
Tom
consistent.
tell you put it in cents, or did you just arbitrarily
I
say,
made it up.
Put it in cents.
I put it. I said
All right.
because it was in pence.
Or-
It was in English. It was
Oh my God.
yeah, CIE. Yeah.
Oh.
So I converted it to hopefully something we would make better sense of. Okay. So now, how does this work? What does this tell me to do? Okay. This says what is the probability of the winnings when this happens, right? So when does that particular scenario happen? That we. So it's what numbers, right? It's
1, 3, and 5.
1, 3, and 5 out of a total of 6. So would you agree, it's 3, 6. Okay, what's the next scenario? 2,
4.
right? So 2 out of the 6. And then last but not least, yeah, which makes sense. They're not going to make much money if you get 3 out of 6 to be the one you get the most money for, right? And again, do your total. You don't have to write total at the end. I suggest you do, just in case. And then you know it's 3, 4, 5, 6, 6, 1 whole. We're good to go. Okay, yes.
Wait, I'm so confused. How did you get the negative 50?
Okay, because I remember I paid 50 cents.
Okay.
I roll a 1.
Uh-huh.
I lose my money.
Oh, so then you have negative money.
Right. Does that make sense?
Yeah.
Yeah. Okay. Everybody good?
Yeah.
See, the important part of these things is to know what your title is.
Mm-hmm.
To know what you're looking for. If you get this part, the rest comes pretty naturally.
Mhm.
Okay, let's do another. All right, I have a random variable, okay, and I'm going to set it up. I'm going to give you this information. This is big X. I have a really hard time.
Mhm.
Okay. Okay. First thing I'm gonna ask us to do is find K, and then construct a table. Okay? So, there's really no story here, but we figure we can find K first and foremost. So, what do I do? How do I go about finding K? So here's the thing I need to ask you is, what do these represent?
Input
Um,
things.
Input things,
mhm.
okay?
I don't know, what do you do with them? You organize them?
What do you do with them? Yeah,
Well, can't you set it equal to 1 because if the total always has to be 1?
okay, what are we gonna set to 1? Very good. So I know in the end, equals 1.
Are we going to have a system of equations and we're going to use substitution maybe?
Not so much, you're not gonna have that. It's a system of an equation, but not
You like
equations,
set up like you plug in one and plug in two and you add all of them together.
because they have to add up to one whole, that's right. So I know that these little guys that are just inputs is actually at the top part of my table.
Mhm.
When x is 1, when x is 2, when x is 3, when x is 4, right? And the probability when x is 1 is blank. When the probability when x is 2 is blank. And this is what we call a piecewise function. And what this is when it's 1 or 2, it goes in here. When it's 3 or 4, it goes in here. Does that make sense? So when I'm using the number 1, I plug it in here.
Uh-huh.
So what is it when I plug in a 1?
3K.
I get 1 plus 2 is 3, so it's 3K. What is it when I plug in a 2?
4K.
4K. How about when a 3 comes in?
3K.
Again, I have to
3K.
plug in here now,
Right.
so it's 3K. And then last but not least, 4K, all of those should total
1.
1 whole. Does that make sense?
Mm-hmm.
The idea is that every probability that happens in this particular function always should add up to 1. And the only thing that we're worried about is 1, 2, 3, and 4, because that's all they're telling me that we care about.
And you just chose those numbers, or
They were given. They're given. Yes.
Were they given to you in that format
Yeah.
like that you wrote it?
Yeah, just like this. So if I clean this up a little bit, I got 8 and 6, which is what? 14K is 1. K is 1/4. 14.
1/4.
14.
14.
So, are we good?
Yeah.
That 1 came hard. So how do we set up the table for this? So what should be on top?
Well,
Yeah.
Big little.
Baby X, right? And then 1, 2, 3, and 4. Okay, are we good? On the bottom, the probability X of X.
Mm-hmm.
Is everybody confident with this so far?
Mm-hmm.
Okay. How about with a 1? Okay.
3 times.
Remember, this represented 1, this was 2, that was 3, that was 4. So we can go back and use those. So what would this be? 3K. Well, K is what? 1/14.
Yes.
So what is this guy here?
3/14.
3/14 is correct.
Wait.
Okay, so 3K, remember we plugged it in? We got 3K. Well, what is K? 1/14. So it's 3 times 1/14.
Why don't you?
Remember, 3 times 1/14 would be 3 over 1 times 1 over 14.
So you don't change 3 over 1 to like 42 over 14.
Only when you add.
Only when you add them. Yeah.
Yeah.
Yeah. So what's 2 gonna be? 4/14.
Uh-huh.
And don't reduce them, because you know eventually you wanna check to see if it adds up to what?
1 whole.
Right. What is the 3 going to be?
3/14.
Okay, 3/14,
And 4.
and then 4/14.
Mhm.
And does it add up to the 1 whole that we're looking for?
Mm-hmm.
Yes. Any questions so far? Are we good? We like it? It's really not hard.
No.
These would be considered more difficult type problems.
Really?
Oh, yeah.
These seem so easy.
They're not bad. Right, this whole chapter is not bad. Okay, so,
We learn about it when we said this other thing.
what's that?
Like the harder versions of it.
No. What you see is what you're doing.
Mhm.
Okay, one more. Yes, any questions? No? Good. I don't think I have answers today. I think everybody is so ready for spring break.
Mhm.
Yeah.
really, 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 really.
Yeah. Mine's 2 weeks.
So long. Okay. So, let's see what I got here. I'm gonna tell you that f of 1 is equal to 0.2. These are given. F of 2 is equal to 0.9. F of 3 is equal to 1. Okay? We're going to construct a table given this information. Okay? So this is just a little different than what we're accustomed to.
Is
Okay?
A 1, 2 near the top, and then the 0.2, 0.9, and 1.
Well, yes and no. Okay? So the 1, the 2, and the 3 are definitely on the top. The x, the little f, the little x is what we plug into, right? And I know the bottom is going to be x given little x, right? So, by definition, let me give you this. F of x is going to be the probability of x, which is less than or equal to little x. Okay? We started, this is kind of a given from here on out. And it's not on the bright colored sheet of paper, unfortunately.
So that applies to everything?
Anything that give you a function,
Why?
f of x. It's just I know, it's just, a theorem that they provide you. What it means is that when I have a function of something, it's always going to be that particular number and everything before it. Because how did we handle this just a second ago? It made sense to us when we did it. Like we had f of less than or equal to 3. What was that by definition when we did it?
1 or 2 or 3.
1 or 2 or 3. Same concept here. Okay?
I have a question.
Yes.
So the f of x, that x is the same as the last x? So like, it would be like f of 1 equals a probability of x is less than
Or equal to
1.
1, which means,
So it wouldn't 0.2 end up being the probability of f of 1? So
the only one that's consistent, and I'm thinking that's what you're talking about, the only one that's going to be completely consistent is the f of 1. Because what is before it? Nothing. So what is the f of 1? It is 0.2.
Yeah.
Does that make sense?
Uh-huh.
That's a given. And what do I know they have to total up to?
1.
They have to total up to 1 whole, so keep that in mind. Okay? So they have to total up to 1 whole. So now what?
Well, because if you add those up, that's not 1 whole. That's it's more. Yeah.
Plug in 2.
So what would f of 2 be, by definition? Think about that with me for a minute. Yeah?
0.9 minus 0.2
Why?
because they're because like f of 2 is f of 1 plus f of 2.
Right.
You're adding each one each time.
Right, because remember,
I
we
get
just,
that.
what we just did, like, okay, let me remind you, look at your one that you have down on your paper, a couple before. Where was it? One right before the, we gambled. Did we gamble? Yeah, no. Which one? Keep going. Did we do one that said f of 3? It was from, we finished it.
We never did that one. 3. We never did episode 3.
I never did it?
I don't remember doing any f of anything.
With the C problem.
Oh, we did a C.
Oh,
You just-
yeah.
Did I totally mess
It
up?
was just like 1, 2, 3, 4, 5 across the top, and then it was C, 2C, 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 1C.
Yeah, and then I started the day off with this, where I said P of T is less than or equal to 3,
Oh, that 3. Okay.
right? And then you guys told me, you knew for a fact that P is 1 plus T is 2.
Yeah, we just did that today.
We did it today, right. And without me giving you the equation, this equation here, you guys, like, deduced this. Did that make sense how that worked out? If it's less than or equal to 3, we know it has to be at least 3, it could be a little less or less. So it's a total accumulation of all of them. So, Nick, go back to what you said, because you were 100% right.
See, it'd be 0.9 minus 0.2, so 0.7. And then-
let's talk about why it's minus that. Let's talk about, first of
Yeah.
all, what is the definition of f of 2? F of 2
Mhm.
is p of, what is it? X is less than or equal to 2. So
Yeah.
Nick, tell me what that would be.
So f of 2 equals p of x is less than or equal to 2. So it would be, p of x is 1 and p of x plus p of x equals 2. Kind of like what we had there.
Does that make sense?
Yeah.
Everybody? Okay, you see where t is less than 3, it was 1, 2, and 3, because it added up to there. So now when it's less than or equal to 2, it's 1 and 2,
Uh-huh.
right? It's 1 or 2. And so that is equal to that. Yes.
So does that mean
So that, what is f of 2 equal to?
1?
0.7.
What is that? Point
But
9.
couldn't you have found that if you did the whole where you like add them up, make it equal to 1 and
Yeah.
then divide by half?
But you're missing this last guy, so you're not sure.
It's 0.1.
Yes.
Why do you put f and p in some instances? Like f in some instances and p
P
in
is
some
probably-
P is probability.
Oh,
Mhm.
what's that?
F is a function of. It's given as a function rather than just probability, yeah. It's a kind of a new fun thing to do. Okay, what is x is 1? Well, we know
Point.
for a fact it's 0.2, because there's nothing before it to add to. So what Nick was saying, what he recognized, is that he could solve for the probability of x is 2.
Mm-hmm.
And how was he saying it? He was saying 0.9 minus 0.2.
Yeah.
Because he, in his mind, recognized this little formula without really probably knowing that you did that.
It just seemed logical to do
It
that.
meant lot, right. So what would the answer to this be? 0.7. And how do you know it's 0.1? Because it's 1 minus each of these.
And they all add
If
up to
you
1.
add
Because they all should add up to 1.
But if you did that thing, wouldn't you get negative 1? Where f of 3 would be equal to f of 2, or f of 3 would be equal to f of 3 minus f of 2 plus f of 1. So 0.9 plus 0.2 is 1.1, and then if you subtract that from 1, you would get 0.1.
It would be 1.1 minus 1, which is 0.1.
No, wouldn't it be 3 minus 2 plus 1? Like if you write it out like that, it would be
So
f
you're
of
saying
3
f of 3.
equals
Oh, I see what you're saying.
f of
So
3
it's 1 whole.
minus 2 plus 1. So 0.2 plus 0.9 is 1.1, and 0.3 is 1, so it would be 1
saying
minus
negative.
1. Yeah, so that's 0.8 instead of 1 whole. Unless you don't just forget the
Yeah.
negative.
Yeah, you forget the negative. Don't do the negative. I see what you're saying, though.
Wait,
No, in her
Now
mind,
we should write it out because
If you do the equation, like if you write it out like that, you end up with negative 0.1 instead
Right.
of 0.1.
right.
And that doesn't give you one whole.
Or if you think of it this way, you know that this plus we don't know has to equal to
That's what I
1.
was thinking.
Yeah.
Do it that way, right. So do 1 minus the point.
But what if there was 4,
Yeah, but if
right?
there was a 4.
So only on the last one, say 4, you could do that trick with
Right.
the total. And then we know what 1 is.
Right.
And then 2, we do that.
Right.
How do we get 3 then?
3 should be the 3 plus 2 plus 1. Should work out. Now, on an ACE exam, I don't think I've ever seen this come up, but it is definitely in your book, so I wanted to introduce it to you.
I wish
Okay?
it wasn't ACE exam.
Because it makes sense,
It's easy.
it's logic. That would be, I think, probably the hardest thing I'm gonna show you. That's the last of my lesson. Yes,
But will they always give you f of 1 equals
Yes.
0.2 all the way across like that?
yes. They would give you what you need to play with.
And they just want you to fill in that chart like that? And that's it?
Let's look at the worksheet and let's figure out which ones you can and cannot do.
Yeah.
Okay, grab that. Okay. So let's start with you guys all have the new worksheet? Does everybody have it? If the scores are different. Or the score on one of the dice if they're the same. What does that mean? 2 random dice are thrown, right? Let the random variable x be the smaller of the two scores if the scores are different.
Which problem is this?
This is
First page.
May, June 2004. So what
Okay.
could potentially happen if I roll dice? They could be 1, 2, 3, 4, 5, and 6, right?
Uh-huh.
or 1, 2, 3, 4, 5, 6. You guys with me?
Mhm.
And it says, let the random variable x be the smaller of the two scores if the scores are different. So, and if they're the same, it's that one score. So for example, what would the first thing be if I roll a 1 and a 1?
One.
A 1, because they're the same. What about a 2 and a 1?
One.
Because why?
No.
It's the smaller score, right? So 1, what's 3 and 1?
That column is one.
The whole entire column.
And the first row is
Are we good so far? I'll just take it right here. What's the next one gonna be?
two.
So this is gonna be a 1, and then a 2, and then what? Twos. You guys good?
Yeah.
And then, yeah.
Wait, so what
I'm
exactly?
rolling 2 die.
Okay.
And then the score that I get is the smaller of the two scores,
Mhm.
unless they're the same number, and I just keep that number.
Mhm.
Okay, so for instance, if I roll a 3 and a 1, what's the smaller?
One.
One. Yeah.
And then a 2,
It'd be a 2.
then a 3, then what happens?
3.
3 all the way
Three.
down.
Yeah.
Are we cool? And then next,
1, 2,
1, 2, 3, 4.
Four.
We're feeling good about it now?
Yeah.
Yeah.
Okay, keep going.
1, 2, 3.
1, 2, 3, 4,
Five.
5. Yeah.
And then 1, 2, 3, 4, 5, 6.
Yeah. 1, 2, 3, 4, 5, 6. What are my possible outcomes?
1, 2, 3, 4, 5, 6.
Are we okay?
Yeah.
What is the probability I roll a 1?
We've got 2 1s, right?
15 out of 36.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
11 out of 36.
Yeah, is that what you're getting? Right?
Yeah.
Is that what everybody's getting?
11 out of 36.
Okay, how about 2? So 11 out of 36.
9 out of 36.
9.
7 out of 36.
Okay, I'm gonna go with it.
5 out of 36. 3.
And then, what should they add up to?
1.
And do they?
36.
Why do you have 6?
136.
Because I stink. So 27, 32, 33, 36 out of 36. Are we good?
Yeah.
So our construction of the probability distribution table is done, okay? So far, so good. Now, how do I find the expected variance, the expected value?
That's the E of X.
Yeah, the E of X. Okay, so cool, you guys are gonna go like, are you kidding? Okay. So to find the expected value, make sure our numbers are all right. To find the expected value, you take the potential number that you would have gotten and multiply it by that. Plus, okay, this times this, plus, etc., all the way down.
That's all you do.
That's all you do. Answer. Okay, so it's 1 times 11, 36. So this is the expected value of X.
Yeah.
2 times 9 out of 36. 3 times 7 out of 36. 4 times 5 out of 36. 5 times 3 out of 36. And then last but not least, 6 times 1 out of 36. Okay. They say it comes up to be 91 out of 36. Check the work to see if it's right. That is your expected.
That's
Yeah.
easy.
Just leave it.
That's it.
Now what's the V?
The variance is a little different, you use a little formula. It involves that. You square something.
It's the first part of the standard deviation.
Well, remember variance, we did variance. What did we do with variance?